the grid. Here we have the default UV coordinates that we have already worked on several times. Then the resize of the UV map. If we use this UV map in a canvas item shader, we have this default behavior where the texture is drawn only in the part that corresponds to the range from 0 to 1, as the other coordinates correspond to numbers above 1 in both an X and Y axis. Now, in spatial, the default behavior is to repeat the map no matter if the coordinates exceed the range from 0 to 1, which in my opinion doesn't make sense. We can disable this behavior with repeat disable. To repeat the UV map correctly, we use the modulo function, which limits a set of numbers to a given range. So there is a kind of wrapping, where the limit is the divisor and the result is the remainder of the division, as the modulo operator is just a reminder of the integer division. Frac is an optimized version of the modulo function with a constant divisor value of 1. It's always better to use a specific function when programming shaders. We have the divisor, which corresponds to the parameter of the function, the divided, which is the input value, and finally the remainder, which is the result of the function modulo alias frac. The value of the divisor is never reached in the result because it determines the envelope. In this spreadsheet, we have an example with different values and the divisor, which in this case is 1. As you can see, the remainder gets very close to the divisor but never reaches it. In this example, it might as well be a number with several decimal places. Then it goes back to 0 and so on. This way, we obtain the repetition of floating values in the grid. With this grid, we can repeat textures, masks, as well as grid patterns and different effects with the help of another grid that we will see next. Here we have different types of grids, like the float grid we have just discussed. There is the integer grid, which is just using the float function to obtain cells or coordinates here. Though the result here is not clear because the values exceed the range of the RGB space. Next, I will call the following grid the fragmented grid. It is the same integer grid, with the difference that we divide it again by the same number that we multiplied in the float function. This way, we get a normalized UV map, but divided in cells of floating values. Finally, using these three grids, we can generate complex noise effects, as we saw in the previous tutorial, very interesting patterns and effects. Now, I will create a 2D scene and drag the GODOT icon to create a canvas item and show how it works by default by repeating the UV map. So I create a material shader, a new shader, and now I create a variable to scale the map and assign it just to the output color variable. I'm sorry, that's wrong. I have a while within using canvas item. It is as follows. And here we see the UV map. Now, if I assign the icon, you can see the behavior of canvas item, which is the right behavior in my opinion. But if I apply the floating grid with the frac function, we get the repetition. Now, let's do the same with a plane and a spatial shader. So I create a new mesh instance, a plane, a material shader, and a new shader. I call it repetition. Next, I assign the output to albedo. I have to rotate the viewport and we see the map with the scale. If I apply a texture with the new coordinates, we see that we have repetition by default, which honestly is quite strange. I'm going to fix the white tone of the image by changing HDR as sRGB and disabling compression to improve the quality. I'm going to disable the default behavior as it personally confuses me. Using repeat disable. Now it looks like canvas item. If I use a floating grid, I have the same result. Here we have the floating grid, which is consistent with the repetition of the texture. Next, I'm going to duplicate this plane and use the option of Make Unique Recursive and save the shader as iGrid Shader. Then I'm going to use the float function and display it in albedo so we can see the integer grid, which now contains cells that we can differentiate in the viewport because they exceed the RGB space. It's not normalized. I duplicate the plane again using Make Unique Recursive and save the new shader as Fragmented GD Shader. The only thing I'm going to change is to divide the result by the same value. Doing that, we have a normalized grid from 0 to 1 that we can see correctly in the viewport. I duplicate again and save the shader as maskgrid.gdshader. And now I create a new uniform to change the values of the grid. Then I cast to float. I create a fragmented grid, but in the output I will multiply the x and y axis. Now I have to change the shader parameter and we get the result. Now I'm going to use my function file. First of all, the random function that we used previously in the random and noise tutorial. I duplicate again and save the new shader as noise grid. Then I include the file. Let's apply the noise, but this time using the grid. I get a random value from the grid coordinates. Each cell now got a homogeneous value. We obtain a noise effect on each cell. I can change its size. Let's duplicate and save the shader as triangle mask. Now I'm going to rename the variable to grid size. Create a mask using the polygon function and then assign it to albedo. Now we draw the triangle mask but using the integer grid. We can change its resolution using the parameter. Finally, I will duplicate again and save the shader as LED banner. Now, I create a new variable, uniform LED color, and another one, banner color. I choose the colors for the banner. Now, I need the float grid, so I create it using the fract function. I create a new variable, setGrid, and this is a pattern of circles using repetition with the float grid. I imagine this grid as a LED banner and the circles represent the LEDs. Now I create the triangle mask again. And now the next logical step is to combine the mask and the grid of circles to get a result. I'm going to multiply the grid of circles by the color of the banner, and on the other hand, the grid of circles by the color of the LEDs when they are turned on. And I am going to mix them using the triangle mask. we have this result. And now I'm going to adjust the emission of the mask, multiply it by the grid, and multiply it by the color of the LEDs turned on. So I got this effect. I don't like the color of the LEDs, so I change them. I can adjust the resolution. And now I am going to add some animation with the sine function. Here are some other examples using different shapes and rotational motion.